Yeah, great. So it's time for the lightning talk. So I am Hanaken. So nice to meet you, and welcome everyone. So back to the BlinkOn so lightning talk session. So yesterday's session was in-person lightning talks, and today's session is pre-recorded lightning talks. So by the way, so this is not a pre-recorded video. So I am speaking so in real time. If you are skeptical, so you can ask me any question in the text chat, and I'm happy to answer. So anyway, so I am super excited. So we are finally so having a BlinkOn so hybrid, and we have a lot of audience in the main room. And the main room has a giant screen. So this time, so I prepared a giant party popper for you. All right. So it's 3 a.m. in Tokyo. So I need to be careful not to create a big noise, but I think it should be okay. All right. So let's go. So 1, 2, 3. Yay! Right. So let's get started. So we have 11 so lightning talks today. So as always, I asked each speaker to insert one point where they can get a storm of applause. So please find that point and send a round of applause with a heartwarming messages in the text chat. All right, so let's get started.
Unpin and go. No, I suppose this is the issue.
Hi, I'm just working for the coding team. Today, I'm going to talk about service worker performance improvements we are doing recently. You may wonder why we are working on the service worker performance improvement. The reason is that it blocks all the navigation. To distinguish if the service worker won't be used for the page or not, the service worker registration must be loaded before going to network fetch. For example, the browser should not send the traffic to network if the service worker is used and returns the page from the cache API. If the service worker is used, the page load will go through the service worker related code, and improving the performance improves FCP and LCP. Where we see the opportunities, we think to look up all service worker registration and code to run the fetch handler. We address the first opportunity with this way. Since the service worker registration must be loaded very beginning of the navigation to distinguish the page used service worker or not, the load of the registration blocks navigation. Its effects was huge on Android. We solved that by moving the most of service worker tasks from crowded UI thread to IO thread, and remained UI thread execution to be done with high priority. The next opportunity is that code to run the fetch handler. We think 3 approaches, especially we recently tried the second one, skips the service worker startup and fetch handler execution if possible. I will talk about that from the next slide. We skip starting service worker for empty fetch handlers. We call empty fetch handler if its function body is empty. It is likely to meet the requirement for to home screen prompt. Soon, this requirement will be gone. However, we suspect that most sites won't update, so we thought that we could help by automatically skipping empty fetch handler. It is done with simple bytecode analysis and easy to implement. This is the implementation details. The browser remembers if body is empty or not in service worker version and registration, and skips starting service worker if it is empty. Also, the renderer skips using service worker for sub-resource load in this case. This is a takeaway from our recent investigation on a popular site, and we keep on working on it in this area. We are open to discuss ideas and risks. If you have any questions, comments, please feel free to send me an email directly or start discussion in BlinkOn BlinkDev. Thank you.
Hi, my name is Wilson, and I'm working on BlinkOn. In this lightning talk, I will talk about our plan to use the open source WPT runner to run web platform tests in Chromium. First, a little background on how we are running web platform tests now. From the diagram, we can see we are using runWebTests.py to run web platform tests. We will then use the baseline tool to create baselines for some type of tests. We then use test expectations to suppress remaining failures. The same process is also applicable to non-WPT tests or legacy layer tests. At the WPT upstream, the test runner used is WPT runner, and the tests are run mostly without the test expectations. So what are the pain points? We see three major issues here. Fifth is that when adding new features to WPT runner, we need to make the same change again in run web tests. This makes maintenance a headache, and it is not always possible to keep the two test runs aligned. There are actually subtle differences between run web tests and WPT runner. Testability, run web tests only works with content share, but there are features that are only available in Chrome. Run web tests cannot run tests with Chrome, Android, or WebView either. Brittany's baselines assert on both test results and behaviors. We only want to assert on results. Assert on behaviors will cause unnecessary baselining, or even flagness if a test produces different output on each run. A timestamp is one such example. To address those challenges, we plan to use WPT runner plus content share to run WPTs starting from Q3 2023. Content share will continue to run in protocol mode at the beginning and switch to Chrome driver in the subsequent change. By doing this, content share, the testing target, will run in exactly the same way as before. And hopefully, make the switch easier to handle. We will set up another Linux-only builder that runs WPTs with WPT runner and Chrome. The plan for Android side browsers are not finalized yet. It is not possible to run all of its own secret yet because running tests in emulator is slow. An immediate mitigation plan is to run a subset of tests that are more relevant on mobile environment. By doing this, we solve the drift problem because we now always use WPT runner to run WPTs. Testability is not an issue because WPT runner supports all kinds of browsers. WPT runner uses metadata, which asserts on test results only, and won't have the same problem baselines had. Current status. We have been working on the project for more than 1 year. We investigate and input WPT runner performance. We build the tool to update metadata based on the test results on builders. We are working on improving WPT runner to support existing features of run web tests, such as support virtual tests, flag specific configurations. Finally, we are fixing issues to make WPT runner to work on Mac and Windows. Here's a diagram on what it will look like after we have successfully migrated to WPT runner. We will have run WPT tests.py, which is a wrapper of WPT runner to run WPTs for all kinds of browsers on all platforms, and uses Blink tool update metadata to maintain test expectations for WPTs. Legacy layer tests will continue to run in the same way as now, but we encourage developers to write more WPTs and start to convert existing legacy layer tests to WPT. And that's it. Thank you for listening. Please feel free to reach out if you have any comments or questions. Bye-bye.
Hello, I'm Byung-woo from Igalia. I would like to share some updates since the previous BlinkOn. More than 50 CLs had been landed until the hash enabled. It added more than 3,000 lines of logic and 11,000 lines of testing. It passed all the test cases and the performance was reasonable. The selector testing time, the restyling time, and the cache memory consumption are well controlled. There were plans to do more remaining tasks after it enabled. So based on this progress, the has pseudo class was enabled in the Chrome 105. It enabled with the 5 limitations based on the existing spec or the resolved spec issues. And I dreamed that everything would be as expected, but it didn't. I have fixed 6 invalidation bugs after the has enabled, so I'll quickly share the cases one by one. The has invalidation didn't work properly with a display none element, and it was fixed in 106. A style was not applied after the page loaded when the style used has sibling relationship and the page was previously rendered with a partially parsed document. This was fixed in 107. A jQuery selection failed when it used jQuery custom selectors inside has. A workaround was applied to the 105, and we are currently trying to apply the changed support behavior to address the issue properly. The has invalidation didn't work properly when an element was wiped out by assigning a value to the inner HTML property, and it was fixed in 108. The has hover invalidation didn't work properly when there was another non-matching has pseudo class on the same anchor element. It was a regression of 106 and was fixed in 108. A has containing style will not be cleared by an element remover if the has initially matched its anchor element and the removed element has a previous sibling element, and it was fixed in 108. It is pretty obvious, but the lesson I've learned while reviewing these failures is that it is important to improve the code quality and increase the test coverage to prevent these failures. Okay, please see the slide in the link for more details, and if you see any other bugs, please report it. Thanks for listening.
Hi, I'm Daniel from the Chrome security team at Google. I'm going to give a quick overview of ways to manage stack seals in Jarret. Using branches is the default mode in Chrome. Each seal gets its own branch. You create a new branch and start adding commits to it. Typically, each seal has multiple local commits as you add tests and fix bugs. Now suppose you want to create a second seal that depends on the first seal. You create a new branch, tracking the branch for your first seal, and then you make commits for part 2. A lot of the tooling works well with this. Git seal archive and git seal issue all understand how Jarret seals are associated with a branch, and git seal upload understands dependencies between seals using upstream branches. One problem is that rebases can be kind of hard. Before rebasing the myFeature2 branch, you have to rebase the myFeature branch first. Git rebase update is a script that can help with this, but it doesn't always work, for example, if you have a lot of local branches like me. It's also not uncommon to have a rebase that runs into conflicts for each local commit. You fix up one set of conflicts and continue, only to run into more conflicts at each step. It's pretty hard and sometimes error-prone, especially with larger seals. And then you need to rebase the dependent branches as well. One way to reduce this pain is to squash all local commits into one with a helper like git squash branch. But if you're squashing all commits into one, does it still make sense to use branches? As it turns out, git seal has an alternate mode called no squash. You can enable it in various ways. With this mode, each local commit corresponds to one seal in Jarret. Each seal's description is taken from the corresponding commit message. To reuse the earlier example, developing a new feature might look like this instead. You create an initial commit for part 1 of your feature, amend it a couple times to update the commit with new tests and bug fixes, then use a separate commit for part 2 of the feature and amend it with bugs and tests as needed. When you upload the branch, Jarret automatically creates a seal out of each local commit. What if you need to revise an earlier commit? Git has the concept of fix-up commits, which you can create using the fix-up flag to git commit. Then you need to run this through an interactive rebase to turn this back into 2 local commits. You start the rebase, you'll probably want to use autosquash, which understands certain naming conventions in git commit messages. This opens your editor of choice. If you use autosquash, the to-do list will be populated appropriately with the previous commit message hints. There's a lot of powerful functionality exposed here. For example, you can also use edit instead of pick to go back and split a commit into 2. Once you close your editor and the interactive rebase finishes, you'll have 2 local commits again. The commit hashes will have changed, but that's okay because git seal uses the change ID footers in each commit message to associate it with a seal. Using no squash enables some neat tools like git absorb. Suppose you get feedback in your CLs, you can make all the edits, and then git absorb will magically try to absorb each edit into the correct commit. If you need to split up parallelizable changes, this can be faster because you don't need to keep switching branches, and rebasing can be much easier than juggling a chain of upstream branches. There's some downsides too, though. I've been using this for about a month, and I've really liked it a lot, and if you haven't tried it before, it might be worth a shot. Thanks.
Hi, my name is Jacobo. I work on Chrome accessibility at Igalia. I would like to give you an update in our work about accessible name computation. Names are an important part of the web accessibility. Interactive elements must have a name that can be spoken up or printed in Braille by assistive technologies, so users of those technologies can figure out their purpose. And we have a spec for this matter, which documents how the different elements and properties interact to conform those names. 1 year ago, we reported our work in this area. We landed many tests. We filed issues on the spec. We fixed bugs in Chrome, and we also cleaned up our implementation. I would like to talk about one of those issues we filed to the spec. It's a case of ambiguity in the wording, and it's about naming from hidden content. The main use case for naming from hidden content is tooltips like the ones you can see here. It's supported by the spec, and it says that if a node is hidden, but it's directly referenced by area labeled by or described by, then it can be used for naming. The point here is directly referenced, because you might think that only direct children of that label would be used. For example, here we have a hidden div, which is directly referenced by area labeled by, and it has children. What should we do with those children? Well, the actual implementation in most browsers are actually exposing the entire subtree, the entire hidden subtree in the name. We also found more differences in implementation between the different user agents. So we joined the discussion. We talked a lot about the original intent, the purpose, the use cases, and we even went through several proposals, and we managed to prototype them. In the end, we settled in the most simple possible change, which was to document what browsers were already doing, which is exposing the entire hidden subtree. We only changed one sentence in the spec, although we added a lot of comments and examples, because I think those help implementers much more than the raw spec text, so to say. If you want to know more, I've been documenting our work in accessible name computation in a series of blog posts, and this is the first one of the series. Well, you know the saying, naming is one of the two hard things in computer science, right? Thank you.
Hi, I'm Kishi, and I'm going to give you a quick update on the Miracle Pointer project. This will cover progress we've made since our breakout session at BlinkOn 16. We covered more of the details then, so if you want to learn more, please check that out. Let me start by quickly recapping what Miracle Pointer is. Miracle Pointer is a technology that protects users from use-after-free exploits in the wild. Unlike tools like ASAN that try to detect use-after-frees, Miracle Pointer's objective is to deterministically prevent use-after-free bugs from being exploited. We have implemented an algorithm we call backup ref retr that quarantines read memory as long as there is a dangling pointer pointing to it. Avoiding the memory from being reused prevents the attacks. The big update from last BlinkOn is that we have actually shipped. In June, we launched Miracle Pointer for the browser process on Windows and Android. In August, we started experiments for Linux, Chrome OS, and Mac. In September, we expanded coverage by enabling Miracle Pointer for all processes except the render process on Windows and Android. And the security benefits it has shown were great. Of all reported use-after-free security issues, 60% were protected by Miracle Pointer. So Miracle Pointer provides amazing security benefits, but there's no free lunch, and the main cost is performance overhead. Here's the latest performance overhead measurements collected from the wild. First, you can see there's memory overhead. On Windows, the total memory usage is increasing about 1.4%, and on Android, up to 2.9%. As we talked about in the BlinkOn 16 session, this is mostly caused by having to store the reference count for each allocation. The jank metric tells us we have an increase in main thread contention. And on Android especially, there's a small impact on startup time and web content responsiveness. So we are keeping a close eye on the situation, but the performance overhead is in line with our predictions prior to shipping. Next, let me show you our roadmap and the progress we've made. This is the roadmap for what we call Miracle Pointer V1. We are close to having a complete Miracle Pointer feature set up and running on Windows and Android. What is left is to enable a planning plugin that enforces raw PTR usage. This is our roadmap beyond V1, and we are making great progress here. In terms of increasing protection coverage, as I mentioned earlier, we want to add more platforms. We have implemented a new type to support reference fields, and you will start to see them soon. We have begun working on the first third-party library to have Miracle Pointer protection, and that will be PDF. We are also working to have some Miracle Pointer protection in the performance-sensitive render process. Another area we have a big focus on is increasing debuggability. Miracle Pointer's primary feature isn't to detect use after freeze, but we still want to be able to detect problems early and fix them proactively. So the Paris team has been working on a dangling pointer detector, and great progress has been made there. Also, we have been trying an alternative algorithm that can detect more kinds of issues. So more exciting things to come from the Miracle Pointer project. Lastly, I want to thank the entire team whose work I talked about here. Thank you.
Hi, I'm Philip. State of CSS is the biggest web developer survey on the topic of CSS, and it's just finished running for the 4th year in a row. This year, we reached a record number of developers, more than 14,000 developers from around the world. A large part of the survey is about features, asking web developers which features they've heard about and which they're already using. This part of the survey is pretty fun. It's a bit like a quiz about new features, and this is probably why many developers take the survey. Let's take aspect ratio as an example. The aspect ratio property makes it easy to control the aspect ratio of an element, and it's replacing terrible hacks involving extra padding from the past. So if we look at the results, we can see that both awareness and usage of aspect ratio is increasing year over year. This matches the usage that we see from Chrome's use counters, with usage growing steadily over time. Another part of the survey asks broader questions about CSS to gauge what web developer sentiment and needs are right now. One of these questions is about browser compatibility or interoperability, and asking if there are any existing CSS features that you have difficulties using or avoid altogether because of lack of browser support or differences between browser. Now, this is a free-form question, so developers could write anything they liked. Let's take 2 examples. One developer said, I really want container queries to have more cross-browser support, but I can't use them yet for that reason. Another developer said, I'm very excited about has getting proper support, but I can't use it until it does. So both of these are pretty representatives of the kinds of responses that we get. If we categorize the 2,000 or so responses into buckets, we get a ranking like this. Container queries is clearly a very in-demand feature, as is the had selector, solving the age-old need for a parent selector in CSS. All right, so what do we do with results like these? Well, one thing we'll do is use these results for the planning of Interop 2023. So that's an effort to improve cross-browser compatibility, and we want to focus on clear web developer needs. So just like last year, we'll use the results of State of CSS when evaluating the more than 80 proposals that we have. Both container queries and the had selector are proposed for Interop 2023, and these results make the rationale for them much stronger. If you want to hear more about Interop 2023, please join my breakout session on that. If you're working on CSS and Blink, then maybe you can get insights from the results as well. Please just head on over to 2022.stateofcss.com and dive in. The results might still be behind a password, and if that's the case, just ask me and I'll share. Thanks all.
Hello and welcome to Standalone Partition Outlook. Representing the Chrome Memory team, I'm Calvin Lee, and I'll be leading you through today's presentation. The agenda is quick. We're going to cover what has been done, what is being done, and what is yet to be done. Part 1, the motivation. Partition alloc is too much to explain. It's Chromium's custom memory allocator. It used to be called with explicit alloc and free functions, but that's not really true anymore. See our documentation for details. PA is built for speed and security and customizability. To learn more, read partitionalloc.md. Now, because partition alloc is speedy and secure, other projects will want to use it. But one thing partition alloc is not actually all that extractable. It won't build outside of Chromium, and other embedders cannot be asked to simply pull down all of Chromium just to get at partition alloc. Therefore, the motivation for standalone partition alloc is born. Part 2, things we've already done. We've got a separate repo already, so people can just embed partition alloc straight from this Git repo, pulling it in through gclient's deps system. We've had a subset of Chromium's base library made, on which partition alloc depends heavily. We refactored the build to separate some Chromiumisms so that embedders don't need to worry about a bunch of vagaries specific to Chromium. And we've actually rolled up the version of partition alloc used by PDFVM, so they're actually quite close to head when it comes to partition alloc usage. Part 3, things we're doing now. There's lots here. I will zoom in on taking over the allocator shim, which enables us to actually power so-called partition alloc everywhere, by which when you call either malloc or free, you're actually getting partition alloc rather than, say, your system allocator. The other thing is the bottommost bullet point, raw ptr.h, which is yet another flagship product from the Chrome memory team, Miracle Pointer. Partition alloc is the lodestone for this, so it forms the basis on which we may stand Miracle Pointer so that other people can use it to improve the security of their projects. Part 4, challenges and difficulties. There's also lots. You would think mirroring base is a simple matter, but over 10,000 lines of code and tons of human hours put in, it was not easy. There was a lot we had to do to get it done. If you read the bug, you'll get all the gory details. The other thing is deciding on policies. We don't really know, for example, how we're going to roll up C++ versions, how well MSVC is to be supported. Do we even have a policy on what happens when we discover improvements or changes, substantial ones, in Chromium's base library? These are yet to be decided. Part 5, aspirations. We want to bring in our unit tests. They currently don't build as part of PA, but we would like them to. We want to provide more build scaffolding so embedders can more easily deal with it. And we want to become your system allocator so that we can blunt more memory safety bugs through Miracle Pointer. Big thanks to the PDFVM team for rolling up PA, doing all the heavy lifting, and thanks to everyone on the Chrome memory team for their hard work here. And thank you for listening.
My name is Adam Rice, and I'm here to tell you about the horrors of the HTTP cache. There are many caches in Chromium, including 3 in this picture, but I'm going to talk about just one. The HTTP cache is a layer in the middle of the HTTP stack in the network service. It is sometimes called the disk cache to avoid getting confused with the memory cache in Blink. That is also confusing because there is something else called the disk cache, which is a lower level key value store that the HTTP cache uses. This talk is not about that. But before we get to the horror part, here's a nice state machine. Chromium's network stack has lots of state machines, and they're all written in a common style. This style works well for state machines that are executed in a roughly linear order, and where each state transition can be either synchronous or asynchronous. This is the state machine for the HTTP cache transaction class. Notice the comment. Normally, states are traversed in approximately this order. That's what we programmers like to call dramatic foreshadowing. Here's the order the states are actually traversed. As you can see, we start in the top left and end around the middle somewhere. This is not completely accurate because some state changes are triggered externally to the class. The HTTP cache implementation is split between 3 files, and this is the state machine of just one of them. I should emphasize that there are no villains in this horror story. This situation was arrived at by smart people making rational decisions. This brings me to a project the web networking team in Tokyo has been working on, cache transparency. The part relevant to this talk is the word cache. I modified the HTTP cache for this project. Everything was great, and we started the experiment. I had 3 new crash bugs overnight. I couldn't reproduce them no matter what I tried. Looking at the code, they were clearly impossible. I disabled the experiment. I spent weeks scouring the code, adding checks, weak pointers, all that stuff to no avail. It was only when my coworker Yutaka had the genius idea of leaving the crashing experiment turned on to rapidly iterate that he was able to track down the cause. There was a subtle invariant in the timing of a particular callback that none of us had spotted. Yes, we have tests. We have over 14,000 lines of unit tests with 95% coverage, but it still doesn't cover all the invariants. Our cache transparency experiment is running now, but we've learnt we can't safely modify the HTTP cache code. In 2023, we plan to change that. This talk doesn't have a good place for applause, so here's a kitten picture instead.
Hi, I'm Richard. I work on the Chromium team at ARM. Our mission is to ensure ARM's the best platform for browsing the web, which involves getting the strongest possible combination of security and performance. We've been focused a lot on security this year, deploying PAC and PCI, as well as getting Chrome ready for MCE. So now it's time for a bit of performance. And essentially, we have three options. We can make complicated changes to Chrome to try and get it to work better on ARM. We can add more ARM optimized code in places where it matters, or we can tweak the compiler flags. So currently, ARM contains lots of instruction set extensions which are very useful for performance, but we can't use them on every platform where Chrome runs. Currently, we have to do something like this, where we detect the CPU's capabilities and change the control flow based on what we find. There's a data-dependent branch in here, which, even if it's trivially predictable, wastes resources. ifuncs are a solution where essentially we annotate the functions that we want to multi-version with this ifunc attribute, which points to a resolver. When Chromium starts up, the dynamic linker calls this resolver, and we figure out which CPU we're running on, and then return an implementation of that function. The dynamic linker rewires everything under the hood so that when we call our multi-version function, it just does the right thing without any further branch prediction overhead. This means that we can have one binary to rule them all, which will work on any ARM system, but which can also be well optimized for every ARM system. So there are lots of reasons to use ifuncs to get access to ARM v9 features. They're very easy to use, and they open up a lot of possibilities, including getting the compiler to automatically generate highly optimized versions of the most performance-sensitive functions. The main drawback is that they don't work well with the crazy linker, so we're hoping to remove the crazy linker or retarget it at 32-bit only builds this year. Now we can talk about the one weird trick, which is to sweep the compiler flags. Our strategy here is to use PGO for ultra high-end builds and AFDO for everything else. Both are very effective at making things go faster without a huge uplift in binary size. We've been doing a lot of work with the Chrome OS team to get AFDO working better on ARM systems, and matching up the target architecture with the collection architecture makes a really substantial difference to performance. How much? Well, the result is that if we apply an AFDO profile from an ARM platform, we can get a 14% uplift in speedometer scores for a 1% increase in binary size over what's shipped today. For ultra high-end devices, we can also switch on PGO, which gets us an even better score at the cost of some extra binary size. We think that with ifuncs, function multi-versioning, and ARM's new vector extensions, as well as native architecture-sourced PGO and AFDO profiles, we suddenly have a lot of options for improving performance on ARM. So thanks very much for listening, and have a great BlinkOn.
Hi everyone, my name is Matthias, and let's talk about WebDriver BiDi. You might have heard of WebDriver or WebDriver Classic before. It's a browser automation protocol defined as a W3C standard with implementations across all major browser engines. Implementations are in Chrome Driver, Gecko Driver, and WebKit Driver. Chromium also has its own proprietary browser automation protocol. This is CDP, or the Chrome DevTools protocol. And this slide captures some of the differences between these two protocols. At a high level, we can say that WebDriver is an interoperable standard, but the protocol is less efficient and lacks features that CDP has. CDP, on the other hand, is more efficient and powerful. It supports bidirectional messaging, but it's less interoperable. And that brings us to WebDriver BiDi, a new standard browser automation protocol that bridges the gap between these WebDriver Classic and CDP protocols. It's really meant to be the best of both worlds. The WebDriver BiDi effort involves standardization work, the creation of web platform tests for the things that are in the spec, and also implementations across the different browser engines and drivers. In Chromium, we're implementing WebDriver BiDi as a translation layer between BiDi and CDP. At a high level, the idea to build on top of CDP is roughly similar to how WebDriver Classic leverages CDP behind the scenes. This layering decision helps us to avoid shipping and maintaining multiple automation protocols in Chromium itself. So CDP remains the only automation protocol in Chrome, but we can still ship multiple protocol support in Chrome Driver. The implementation of the WebDriver BiDi protocol lives in a standalone repository, which you can see the URL of here. This helps us to iterate and prototype quickly without blocking the Chromium tree. The BiDi CDP translation logic is expressed in TypeScript, allowing us to build a single JavaScript bundle at compile time that we can then run inside of a Chrome tab. And on the Chrome driver side, we've worked to land the necessary architectural changes to enable embedding this translation layer. The result of all of this is that Chrome driver 106 shipped with support for the WebDriver BiDi standard. This makes it possible for frameworks like Selenium and Puppeteer to start experimenting with the new WebDriver BiDi protocol. At the same time, it's still early days, and we're continuing to flesh out the WebDriver BiDi specification in collaboration with other browser vendors and other industry stakeholders participating in the W3C working group. As we specify more features, we also create web platform tests to verify the implementations. So if you're interested, please subscribe to our repository, and thank you for listening. Take care.
Oh, geez. Oh, no, that's not the one I want to do. 10. All right, Kentaro, go ahead.
Yeah, so thank you very much for all the amazing updates and heartwarming messages. So please send another big applause to all the speakers. So thank you very much. Yeah, I'm so excited. So so there are so many non-Google speakers. So I want to have it in the next BlinkOn. So see you at the next BlinkOn. So thank you very much.